Blowfish is a symmetric key block cipher. It was developed in 1993 by Bruce Schneider. It was created to improve upon the Data Encryption Standard, or DES, an algorithm known to be slow and insecure. Let's take a look at how Blowfish works. First, we initialize our key-dependent P box and S box using the hexadecimal representation of pi. For now, we will skip over the details of their creation. The P box has 18 entries and the S box has 256. Next, we take our 64-bit plaintext and split it into half. We'll call the first half L and the second half R. We then enter a loop, which we will repeat 16 times. We take L and then XOR it with PI, the value in the P box at our current index. We then take R and XOR it with a function of L. So what is this function? In the function, we split L into 4 quarters. The S-box value at quarter 1 is added to the S-box value at quarter 2. Then that sum is XORed with the S-box value at quarter 3. Finally, that result is added to the S-box value at quarter 4. Lastly, we swap L and R. Then we repeat the loop all over again. After going through the loop 16 times, we swap L and R once more. If you recall, our P box had 18 entries. We went through the first 16 in the loop, and we now have only 2 left. So we XOR R and L with P17 and P18, respectively. We then combine L and R to get our ciphertext. Decryption follows the same process, but in the loop we would start at P16 and go down from 16 to 1. Blowfish has many pros. It had a good encryption rate, it was resilient against cryptanalysis, and was unpatented and free to use at a time when most algorithms were patented. Its main con was its small block size of 64 bits. So Schneider increased the block size to 128 bits, creating Twofish. Ultimately, NIST chose the Advanced Encryption Standard, or AES, as a successor for DES, but Twofish was still a finalist and has not yet been proven insecure.